Continuation of last class. Two more bidentate negative ligands, carbonate and sulfate. Right? In carbonate, what are the donor atoms? Oxygen, oxygen. In sulfate, what are the donor atoms? Oxygen and oxygen only. Right? Next category. See, we completed a monodentate negative, bidentate negative. Next, keep heading monodentate neutral ligands. Row number 3. Monodentate neutral. Monodentate neutral ligands. Roman number 3. Monodentate neutral. In the first column, what we will write? Name of the ligand, right? Name, formula and symbol. Monodentate neutral. Next, 32. Number 32 only na? Aqua H2O. Formula and symbol both are same only. Amine. NH3. Don't call it as ammonia. This is amine. 34. Carbonyl. CO. 35. Thiocarbonyl. CS. 36. Nitrosyl. NO. I am giving a few important ligands list. Learn them only. First, learn these: aqua, amine, carbonyl. These ligands will come frequently. Aqua, amine, and carbonyl. Okay, note down. Did you finish? Shall we go to next page? Online students. Continuation. 37. Triphenyl phosphine. Triphenyl phosphine. PPH3. PH means phenyl. PH means phenyl, benzene ring. Triphenyl phosphine, PPH3. Important. Give tick mark for this also. Triphenyl phosphine. PPH3 only. Triphenyl phosphine. 38. Important. Pyridine. 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 PY. 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 In this, how many carbons are present? How many carbons are present? C5. 1, 2, 3, 4, 5. How many hydrogens are present? H5. 1, 2, 3, 4, 5 hydrogens. N. So C5H5N. Pyridine also represented as C5H5N. Important. Methylamine. Methylamine. This is easy only. Learn this also. CH3NH2. CH3NH2. CH3NH2 only. Methylamine. Sorry. 40. Dimethylamine. This is also easy because these two based on the nomenclature, amines nomenclature. NH CH3 taken thrice. Dimethylamine. Learn this also. Acetonitrile CH3CN. CH3CN. Next category, bidentate neutral. Bidentate neutral. Bidentate neutral. Bidentate neutral. Name of the ligand, same, everything is common. Okay. In first column, write name of the ligand. Second column, formula or structure. Third column, symbol. Okay. Right. 42 ligand number. Q star mark. Very, very. Q 2 stars or 3 stars or 4 stars. Most important bidentate neutral ligand. It will come in the examples frequently. Ethylene diamine. Ethylene diamine, or it is also called as ethane 1,2 diamine. Ethane 1,2 diamine. Ethane 1,2 diamine. You know ethylene? What is ethylene? Tell me. Ethylene, CH2 double bond CH2. This is ethylene. Ethylene. In ethylene, remove one bond. See, one bond is removed. Now carbon valence is not satisfied, right? So what we have to do? We have to attach another bond. NH2. Ethylene diamine. Ethylene diamine. ethylene amine and amino group diamine. Its symbol is En. Very very important. En. So you have to identify. En stands for, En is a bidentate neutral ligand. What are the donor atoms? Donors. Tell me. What are donors? Nitrogen donors. Give star mark. Nn donors. Very very important. Two similar donor atoms. Nn donors. That is very very important. Ethylene diamine is a bidentate neutral ligand and donor atoms are Nn. Nn. See, sometimes we represent En, okay, like this. N just a curved line. Note on this also. You will get a ligand like this also in some examples. Clear? N and the curved line. You have to imagine in that curved line CH2 is present. In this curved line, what will present? CH2 will present. Okay. First important bidentate ligand completed. Ethylene diamine, En. In 10 examples, En only will come under bidentate category. Okay. Next 43. Next bidentate ligand. We completed one bidentate ligand. Next ligand. Bipyridine. You know pyridine? This is one pyridine. This is another pyridine. These two join together. This is called bipyridine. Symbol bipi. Bipi, or take small letter bipi. Bipi stands for bipyridine. Bipi. Bipyridine or dipyridine. Symbol is bipi. Donor atoms. What are donors? Tell me donors. N, M. Nn donors. 44. Phenanthroline. See, donor atoms, star and star. The last case also give stars for this nitrogen. Stars represent donor atoms. Okay, this is represented as Phen. Phen or Ophen. First one is important. Q star mark for 42. Ethylene diamine or ethane 1,2 diamine. En. Surabhi, are you following? Surabhi, Bhakti. So what I am saying, I am giving tick marks for some ligands. Okay, learn them only first. Clear? All these are which category? Bidentate neutral category. Next 44, right? Tridentate. First write negative. Once give the, see, now onwards no need to draw the table. Okay, no need to draw the table because examples are very limited only. Clear? Once give its name. Can you give its name? IUPAC nomenclature. Propanoic acid. This one, propanoate ion, carboxylate ion, propanoate ion, propanoate. Now, how many amines we kept? We attached two amines, diamino, propionate, propanoate. This part is propanoic acid and this is propanoate, propionate. I have given structure directly, so just write name and the symbol. Diamino, propionate, symbol DAP, diaminopropionate, DAP. Tridentate negative ligand. For NEET level, these are not that much important. Okay? That's why I'm not giving important symbol, but for next one I'll give the important symbol. Tridentate negative. Just once observe the structure and leave it. No need to learn. Next, tridentate neutral. This is important. Keep adding tridentate neutral. See, tridentate nitrogen, and oxygen. Stars. Tridentate neutral. This is important. Keep star mark for this. Tridentate neutral. Tridentate neutral. Important. Once look at this, all of you. What is its name? Ethylene. How many ethylene groups are there? 2. Ethylene. Now remove one bond. When we remove the bond, we have to complete the valency, right? So I am keeping in the middle one NH like this. At terminal NH2 like this. Okay? Got it? This is one ethylene unit. This is one ethylene unit, right? We can write like this also. NH2, CH2 taken twice, NH here, CH2 taken twice because this is present 2 times. NH2, right? Can you give its name? How many ethylene groups are present in this? 2. Diethylene. How many amine groups? 1, 2, 3. So read completely. Diethylene, triamine, diethylene. This is one ethylene, diethylene, amine, diethylene, triamine. Clear. So write name and symbol directly. No need to write any box because one category, one example only. Diethylene, triamine. Generally it is abbreviated as, this is the name, symbol is important, symbol diene, in and diene. Donor atoms are nitrogen. Diene. Which of the following is a tridentate ligand? Tridentate neutral ligand. Answer is diene. Right? Tridentate negative is our tridentate neutral also work. Next, tetradentate negative. Tell me, Adima, Bhakti, any doubt? Surabhi, first year, Surabhi and Bhakti. Surabhi, did you learn ligands list in the last class? Sorry, diethylene. Same only, this is. Actually, this can be represented like this. In the middle, how many CH2 moieties are there? Units are there? 2. So I wrote 2 times, CH2 2 times. Both are same only. Here, what is the important point? Diene. If I ask you, say about diene, what is diene? Which category? Tridentate neutral category. That is important. Tridentate neutral category. Which of the following is a tridentate neutral? No need to learn the structures. Okay. Next, one more example only. Next, tetradentate negative, tetradentate neutral. Tetradentate neutral. First, write negative. Sorry, tetradentate negative. I am not giving important symbol. Did you give important symbol for last one? Give the tick mark for this. For diene, important. For diene. Give tick mark for diene. Next, tetradentate negative. Tetradentate negative. Oxygen is the donor. Oxygen is the donor. Oxygen is the donor, and nitrogen is the donor. See, its name trinitrido. Trinitrido. Triacetato. Nitrido. Sorry. Only nitrido. Just a second. Nitrido. Not trinitrido. Nitrido only. Please correct it. Nitrido only. Nitrido triacetato. Nitrido triacetato only. Symbol is NTA. Nitrido triacetate. N stands for nitrido, T stands for tri, A stands for acetato. For neat, more than half this is means beyond the neat. No need to learn. Just see once and leave it. Okay. Fourth category. Next category, neutral. Tetradentate neutral. This is important. Keep star for this. Shall we go to next page? Online students. Tetradentate neutral. Tetradentate neutral. Tetradentate neutral. Important. Tetradentate neutral. Once look at this, all of you. CH2 double bond CH2. You can remember easily if you learn ligand information, ligand structure like this. Ethylene. How many ethylene groups we took? 3. Clear? 3. What I am doing, I am removing the bonds. One bond here, one bond here, one bond here. What we have to do? Tell me. If we remove the bonds, we have to complete the valency. So I am keeping NH here, here NH2, here NH2, right? You tell me how many ethylene units are present here? 3. Triethylene. Name triethylene. And how many amine groups are there? 1, 2, 3, 4. Tetraamine, triethylene tetraamine, triethylene tetraamine. Triene symbol, you know, ene, diene, next triene, last triene. See, we may get confusion. Triene means tridentate ligand, triene means tetradentate ligands, diene means tridentate ligand. Donors, nitrogen donors. Ene, diene, triene. Okay. Next, last two are very, very important. Pentadentate negative and hexadentate negative. Most important ligands. Pentadentate negative, pentadentate negative, pentadentate negative ligands. No need to draw the table. Once see, Bhakti, Surabhi, Adiba, Ketura. Follow to Naramir, Ketura. If you know how to draw the structure, then you can identify the information. You can identify the ligand easily. You can remember the points related to that ligand easily. How to draw the structure? First is how I am starting. Look at this. Generally, it is a complex ligand. So see the procedure. How I am drawing. What is its name? Ethylene. Ethylene. One bond is removed. Okay. Now, online students, Surabhi, can you give its name? Ethylene. This is a man. This is a man. Tell me. Ethylene. Ethylene. Tell me, Surabhi. Bhakti. Ethylene. Ethylene diamine, right? Wait. Here, how many hydrogens are there? How many hydrogens are there? 2 hydrogens are there. 2 hydrogens are there. Total 4. On nitrogen atom asking. Okay, 4. Remove 2 hydrogens. Remove 2 hydrogens. In place of hydrogens, we are placing acetate groups. CH2, COO negative, donor atom. Okay. We remove 2 hydrogens. In place of 2 hydrogens, we are placing acetate group. CH2, COO negative, star mark. Okay. Here I am removing only one hydrogen, and in place of another hydrogen, CH2, COO negative, star mark. And you tell me, how many donor atoms are there in this? Stars are donors. How many donor atoms are there? 1, 2, 3, 4, 5. Stars are donors. Yesterday I said, na? Star marked atom. So pentadentate negative. Its denticity. What is its denticity? In this, how many donor atoms are present? Denticity means donating capacity only, na? What is its denticity? 5 donor atoms are present, right? So pentadentate negative. Why negative? Why it is negative? Negative. Right. Now you tell me, on this nitrogen we remove 2 hydrogens. On this nitrogen we removed only 1 hydrogen. 1 hydrogen is present or not? Remember that point. Now coming to the name. Ethylene, amino, diamino. This is one acetate. How many acetate groups are there? 3. Ethylene diamine triacetato. And one H we didn't remove. So the symbol is H. On nitrogen atom, one H is there. H. See ethylene diamine, E, D, ED T, sorry, here A, di A, EDTA, H, EDTA. This H is this hydrogen. Clear? H, E, T, A, T, sorry, ethylene diamine triacetate. Wait. Ethylene diamine triacetate. This is correct. Underline that first letters. Now it is correct. HEDDA. And what about charge? HEDDA -3. Charge is very, very important. Charge. HEDDA. Very, very important this is. You should learn. HEDDA is which dentate ligand? Pentadentate. What is the denticity of HEDDA? 5. Which of the following is a pentadentate ligand? HEDDA is the answer. Okay. Ethylene, diamine, acetato. 3 acetate groups are there, so triacetato. EDTA. Ethylene, diamine, triacetato. Clear? Right. Completed online students. Did you finish? Online students. Once see what I am doing. I am removing this hydrogen also. Next category. Hexadentate negative. Hexadentate negative. Yes. What? Because here H is there on the nitrogen atom. This H represent this hydrogen. Okay. Actually NH2 amino group is NH2, right? In here we remove 2 hydrogens. Here we removed 1 hydrogen only. 1 hydrogen is still present on the nitrogen atom. This hydrogen represents this hydrogen. Clear? Now what I am doing, I am removing this hydrogen also. Then I have to remove H here. Clear? And next, ethylene diamine. Tell me, guess the name. Tetraacetato. Ethylene diamine. Tetraacetato. Remove this hydrogen here also. Okay, and the charge also. Here another acetate group, COO negative, star mark. So EDTA, charge is -4. Symbol is very, very important. Last 2 ligands are very important. EDTA, hexadentate ligand. Where are 6 donors? Star 2, 3, 4, 5, 6. Star marked atoms are donor atoms. EDTA denticity is 6. Denticity nothing but number of donor atoms present in the ligand. Learn ligands information as soon as possible. Gives already given, important symbol is given. Learn all important ligands. Clear? In bidentate, you have to learn most of the ligands. In bidentate negative, monodentate negative, I given few important. And today also I given some important ligands. First learn them. Completed? Bhakti, Surabhi. Completed or not? For first year students, tomorrow I will conduct a study hour, okay, because you didn't learn complete list, only for preparation. I'll mention the timings, 1 hour study hour. I'll give the important list, right, without seeing, because every next concept depends on the ligands information only, okay. See, this is one type of classification of ligands. Next category, ambidentate ligands. Keep heading, ambidentate ligands. Most important question, this is also, which of the following is ambidentate ligand? Ambidentate ligand. Sorry, some Adibam, symbol for what? That is only the symbol. This is only the symbol. Ethylene diamine tetraacetato, symbol is EDTA. EDTA -4. This is ligand name. This is the symbol of ligand, EDTA. EDTA -4. If you do not observe H, that is hexadentate. If you see the H, that is pentadentate. Last case is HEDA. Ambidentate ligand, ambidentate. One example I'll explain, Surabhi and Bhakti. Surabhi, answer this. This is mango tree, this is mango. The fruit is little bit height. Then how can you pick the mango? You tell me, Surabhi. How can you pick the mango? By jumping. With one hand or two hands at a time. You will pick the mango with one hand or two hands by jumping. Generally. You don't know this idea. One hand only, na? You didn't play any game in the childhood. You have two hands, but you use only one hand. Simple thing for writing. How many hands you have? How many hands you have? But how many you will use? One hand only. Clear? You can write with left hand also, but writing will be very bad. Two hands. Oh my God. Very big monkey came. Right. We have two hands, but we use only one. Similarly, in some ligands, two donor atoms are present, but uses of only one donor. That ligand uses only one atom to donate to the central metal atom or to link to the central metal atom. That type of ligands are called as ambidentate ligands. The ligands with two donor atoms, but uses only one atom to link with the central atom, are called as ambidentate ligands. This list is very, very important. Pakka this question will come in your first exam. Okay, no doubt, 100% for your weekend exams. What is definition? The ligand with two donor atoms, but uses only one atom to link with the central metal atom. Clear? Two hands, but we use only one. Like, remember that example. Ambidentate means two hands, but we use only one hand. Right, ligand with, write the definition, ligand with two donor atoms, but uses only one to link with the central metal atom. Question coming area, ambidentate ligand concept. Once you can see monodentate negative category, there I given some tick marks. for thiocyanate, cyanide, okay, cyanate, nitro, nitrite, yesterday I given tick marks, all that are considered as a ambidentate ligands. Let us see this. See the list, examples list. First write all the ligands at one place, then we will see how they act as ambidentate ligands. Cn minus, SCN minus, NO2 minus, OCN minus, S2O3 minus 2. Ambidentate. First three are most important. Already you learned that list in monodentate negative category. Again you are learning them separately. Alright, let us take first one. What is its name? Cyanide ion. Cyanide ion. This is central metal atom. Cyanide ion linked to central metal atom with carbon atom. Carbon atom. Generally, we mention that atom which is linked with linked to central metal atom in the parenthesis. Bracket C. I given in the last class. Now it is called as cyanide. Same cyanide ion linked to central metal atom with nitrogen. Isocyanide. Okay. Thiocyanate ion. What is the name of this ion? Thiocyanate ion. M is the central metal atom. Thiocyanate. Linked with nitrogen. Isothiocyanate. Third example. Shall I clear this? Online students. Nitrite ion. First I am giving the name. Sorry, NO2. Name of the ion. Nitrite ion. NO2 minus nitrite ion. See, when nitrite ion linked to central metal atom with N, it is called as nitro. When nitrite ion linked to central metal atom with oxygen, it is called as nitrito. Name will change. Nitrito. When we call nitrite ion as nitro, when it is linked to central metal atom with N. When we call this ion as nitrito, when it is linked with oxygen. Nitrito. Okay. Cyanide ion. Cyanide ion is given at the beginning, right? Clear? Next keep heading. Pi acidic ligands. Pi acidic ligands. Next category. Pi acidic ligands. Pi acidic ligands. This is also generally questions do not come on these concepts, like especially some special type of ligands are there, no? But you have to learn. For weekend exam, in weekend exam you cannot say. Okay. Pi acidic ligand. What is general phenomenon, you tell me? Which atom accepts electrons? Central metal atom. Which donates electrons? Which donates electrons? What is ligand definition? Ligand definition. Ligand means electron pair donor. Surabhi? Correct only, na Surabhi? Ligand means? What is ligand? Bhakti, what is ligand? Are you there? Surabhi and Bhakti. Are you there in the class? Yeah, electron pair donor. See, some ligands first donate electrons to the central metal atom as usually. Okay, ligand is giving the electron. What happens after that? See, again they accept electrons from the central metal atom. Generally ligand means that should donate electrons. That is general phenomenon. But what happens in some ligands, in reverse direction, they accept electrons from the central metal atom. That type of ligands are called as pi acidic ligands. The ligands which accepts electron pairs from the central metal atom are called as pi acidic ligands. Generally ligands only donate electrons to the central metal atom. But some ligands, what they do, first they give the electrons to central metal atom, again they accept electrons from the central metal atom. That type of ligands are called as pi acidic ligands. See the reason. Let us take one ligand CO. Example for pi acidic ligand is CO, carbonyl ligand, very important monodentate neutral ligand CO, carbonyl ligand. You know chemical bonding. How many electrons are present in this? Tell me. How many electrons are present here? How many electrons are present? 8 plus 6, 14. 14 electrons are present or not? Then write configuration sigma 1s2, sigma star 1s2. 14 means here what you will write first? Pi 2px is equal to pi 2py, sigma 2pz. Next, pi star 2px is equal to pi star 2py. Total how many electrons we have to fill? How many electrons we have to fill? 13, 18, oxygen 8, carbon 6, 14. 14 electrons we have to fill. Okay, 1, 2, 3, 4, 5, 6, 7. 7 electrons were filled. This is chemical bonding actually. Chemical bonding topic. Okay, in carbonyl ligand, this anti-bonding molecular orbital is vacant. Anti-bonding molecular orbital is vacant. That's why this carbonyl ligand, I am writing here like this. This carbonyl ligand first donate electrons and accept electrons from the metal atom due to presence of vacant anti-bonding molecular orbital. So reverse process takes place. Clear? First we will discuss, this is a separate topic at the end of the topic, at the end of the lesson. Okay, metal carbonyls under subcategory we will discuss. First sigma bond is formed, after that pi bond is formed. Okay, in metal carbonyls two types of bonds are present. Sigma bond is formed due to transfer of electrons from the ligand to metal. Pi bond is formed due to transfer of electrons from the metal to ligand. Metal to ligand. This is a separate topic, metal carbonyls. Here what you have to learn, what is a pi acidic ligand? Examples over. What is a pi acidic ligand? The ligand which accepts a pair of electrons from central metal atom. Generally, what is the role of ligand? Ligand should donate the electrons to metal, but in reverse direction, what happens? It is accepting electrons from the metal. Write that and examples list. Definition and examples enough. Okay. Ligand which accepts pair of electrons from central metal atom is called as pi acidic ligand. Examples list. CO. अरे monkeys are there. Cl negative. No, it will give first it will give the electrons only. What I am saying, first natural process takes place, natural phenomenon takes place. First carbon will give electrons to the metal, okay. After that again it accepts due to the double bond formation takes place there. Double bond character, bond between metal and carbon is double bond, carbon is double bond. All these ligands give the electrons. At the same time, they accept electrons. Okay. For example, I am giving 100 rupees to you. You are giving 150 back to me. I am giving to you 100 rupees. You are giving 152 or 130 rupees to me, or 90 rupees to me. Reverse. Cn negative. Note down. NO positive, and PH3. Most important pi acidic ligands. Okay. Definition, example list. Ketura follow to namanu. Ketura. కోతులు ఉన్నాయి, మంకీస్ ఉన్నాయి, పైకి రావద్దని చెప్పవాలని. పట్టించుకోకలే కానీ మంకీస్ ఉన్నాయి, పైకి రావద్దని చెప్పవాలని. సరే క్లాస్లో ఉన్నాయి. ఓకే. pi acidic ligands. Next. Very important, keep star mark for this. See, if I draw this symbol, you know already first year students, incoming second years, must and should you learn. Very important. Chelating ligands. Chelating or chelating ligands. Chelating or chelating. Both are same pronunciation. Chelation. Chelating or chelating ligands. Ring forming ligands. Chelation means ring. Ring forming ligands. The ligands which form rings with central metal atom are called as chelating ligands or chelating ligands. The ligands which form rings with the central metal atom are called as chelating ligands. Which of the following is a chelating ligand? Inorganic is completely memory based only. Okay. If you are able to identify the chelating ligand, then you can answer one important type of question. Stability of complexes depends on the idea about chelation. The complex in which a chelating ligand is present is more stable. Okay, that is later. First you should understand, you should know or should remember what is a chelating ligand. Example list. Okay, look at this. One important statement I am giving: except monodentate ligands, remaining ligands can be considered as chelating ligands. Except monodentate ligands. Except monodentate ligands. Except monodentate ligands, remaining ligands are considered as Surabhi, are you following? Except monodentate ligands, remaining ligands means bidentate, tridentate, tetra, and so on. Very easy to identify a chelating ligand. Bidentate ligands onwards. Mostly bidentate examples will come for us. Bidentate, tridentate, tetradentate, all these are chelating ligands. Remaining ligands. Clear? Let us see one example how they form the ring and how questions will come in the weekend exams. For final it's no need of teaching all this excess information for you. Okay, for weekend exams only. The problem is with weekend only, especially for elite people. I am taking ethylene diamine. One example, nickel, En taken twice. Ethylene diamine. What is ethylene diamine? Today only you learnt about ethylene diamine. Ethylene diamine comes under which category, Aisha? Bidentate, negative or neutral? Bidentate neutral. Bidentate neutral. Nickel. See, I am writing ethylene diamine here. NH2. This is CH2. We can write a bond line structure. You know, in nomenclature, we can write like this: bond line structures. Learn today ligands list, all of you. By tomorrow, anyway, tomorrow I will conduct one study. This is one ethylene diamine. Total we have two. So this side I am writing another ethylene diamine. Nitrogen is the donor atom. Nitrogen is the donor. Nitrogen is donor. Nitrogen is donor. Now this is a ring. This is a ring. Clear? In this ring, how many atoms are present? Sorry, count, Aisha. Nickel 1, 2, nitrogen 2. Actually, these hydrogens will attach like this. Okay, I wrote like this. Okay, H like that. Nickel, nitrogen 2, carbon 3, 4, and 5. Because of chelation, a 5-member ring is forming in this. A 5-member ring is, that is also question. A 5-member ring is formed due to chelation. For example, you will get like this. In the following complex, how many atoms are present in the ring? In nickel, bis ethylene diamine, nomenclature is used bis. Okay? I'll tell you later nomenclature. How many atoms are present in the ring? 5 atoms are present. Because of chelation, a 5-member ring is forming here. Nickel is 1, nitrogen 2, carbon 3, another carbon 4, and a nitrogen 5. Okay, so ring form. This is one ring and this is one ring. Total how many rings are forming? 2 rings are forming. 2 chelates are forming. 2 chelates are forming. In each chelate, means in each ring, 5 atoms are present. You tell me glycinato. Glycinato is which category ligand? Glycinato. Sorry, bidentate mononegative. Bidentate mononegative. Let us see another example. Bhakti, follow tunnara. Except monodentate. I'll tell you. During questions you will get. Yes, for weekend, not for NEET. For this is just competition only. Okay. In weekend exams, they will give questions little bit tougher. Clear? Compared to final NEET, your weekend exam only tougher. See, you asked one question. Actually, this will come later. Which of the following is a stable complex? That is the question. She asked what is the need of learning about chelation concept. I given two complexes here, right? 6 ligands are there. Here 3 ligands are there. Which is having chelating ligand. Which is a chelating ligand. That is stable complex. Very simple. The complex which contains chelating ligands are more stable. That is the application. Next example. Nickel GLY taken twice. Nickel GLY taken twice. GLY, what are donor atoms in glycinato? Nickel, glycinato. Say glycinato. Carbon, sorry, oxygen and nitrogen. This is glycinato structure. 2 glycinato units are there. Another one. Now you tell me, in the ring, in the chelate, how many atoms are present? Nitrogen, oxygen, carbon, nitrogen. How many atoms are present in this ring? Circles, count circles. 5 atoms are present in the ring. Because of chelation, a 5-membered ring is formed. Okay. Right, next, flexidentate ligands. Flexidentate ligands. Flexidentate ligands. Flexidentate ligands. See, some central metal atoms are having particular binding capacity with the ligands. That binding capacity is called as coordination number. For example, copper. Copper can combine with the 6 ligands, so its coordination number is 6. 6. Copper needs how many donor atoms? 6 donor atoms. Its coordination number is 6. Binding capacity with the ligands is called coordination number. That is our next topic. Clear? But to understand that definition, we should have idea about coordination number. Coordination number nothing but binding capacity. For example, if I combine with 4 friends, my coordination number is 4. If I do friendship with 6 friends, my coordination number is 6. Combining capacity or binding capacity. Right. Copper is generally having 6 coordination number. A cobalt, all these are having 6 coordination numbers. Once look at this example, cobalt or copper, NH3 taken 4 times and SO4. What? Tell me. NH3 taken 5 times SO4. Once observe these two different. Cobalt needs how many ligands? 6. How many ammonia ligands are there? 4 ammonia ligands are there. Once look at this. Ammonia. NH3. I'm writing just like a tetrahedral structure. For octahedral. You know octahedral in chemical bond. On this plane, 4 corners are present. Okay. In the middle, central atom is present. Above one atom, below one atom, like this. Okay, right. Cobalt needs 6 atoms, 6 donors, right? 1, 2, 3, 4 donors are over. 4 donors are over. You know, sulfate. What is the structure of sulfate? I given see once under bidentate negative category. Here oxygen with a negative, that negative is donated to. Clear? Now you tell me here sulfato is giving how many donor atoms to cobalt? 2 donor atom based on the requirement. Clear? See this one, second one. In second one, how many ammonia ligands are present? 5 are present. More, how many ligands it requires? Cobalt requires 6. Already 5 ligands are present. More, how many? 1. Cobalt, NH3, 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 NH3. Another NH3 also. Right? 5. One more atom. O. SO3. Here sulfate is giving only 1 donor atom. Based on the requirement, it will change its donating capacity. That is called flexidentation capacity. Here cobalt needs 2 donor atoms. That's why sulfate is giving its 2 donor atom based on the requirement. Here cobalt needs only 1 donor atom. That's why sulfate is giving only 1 donor atom. This is called flexidentation. So how to define flexidentate ligands? The ligands which use all donor atoms or few donor atoms present in them based on the requirement by the central metal atom is called flexidentate ligand or flexidentate ligands. The ligands which uses all donor atoms or few donor atoms based on the requirement by the central metal atom. Got it? Hello?
Hello, sir.
చెప్పండి. వచ్చావా మనం?
వచ్చాను సార్ నేను.
ఒక్క నిమిషం వస్తున్నాను. నేను కూర్చో, 4th ఫ్లోర్లో కూర్చొస్తున్నా.
ఇక్కడ అపార్ట్మెంట్
దత్తసాయి నిలయం అని ఉందా బిల్డింగ్? అక్కడ అందులో 4th ఫ్లోర్లో కూర్చో, నేను వస్తున్నాను. బయట టేబుల్ ఉంటుంది, టేబుల్ దగ్గర కూర్చో, సరేనా? క్లాస్లో ఉన్నాను, వస్తున్నాను. Online students, did you get this? Surabhi, Bhakti, Adiba, first years, second years. Bhakti, Adiba. Surabhi, can you explain what is flexidentate ligand? Give general explanation. What is flexidentate ligand? Seeing this diagram, tell me. What is flexidentate ligand? The ligands which use all donor atoms or few donor atoms based on the requirement by central metal atom. For example, I am central metal atom. Okay, I need some 6 lakhs. Okay, you are having some money. Okay, I need 6 lakhs rupee. But one of my friend given 4 lakhs rupee to me. More, how much amount I need? 2 lakhs only. Now you will give 2 lakhs to me. For example, my friend didn't give any money to me. Then how much money you have to give to me? 6 only. So based on the requirement, you will give money to me. Based on the requirement by the central metal atom, one ligand gives its donor atoms. Clear? Cobalt total coordination number is 6. Here already 4 is completed. Coordination number 4 is completed. So 2 more atoms it needed. That's why sulfate is giving its 2 donor atoms. Here cobalt is connected with the 5 already. More 1 atom only required. So sulfate is giving only 1 here. Here it is giving 2. Here it is giving only 1. This is called as flexidentation. Clear? Note down the definition. The ligands which use all donor atoms or few donor atoms present in them. The ligands which use all donor atoms or few donor atoms based on the requirement by central metal atom. The ligands which use all donor atoms or few donor atoms based on the requirement of central metal atom are called flexidentate ligands. Adiba, got it? Adiba. Last cat, yes, tell me. Vesper's theory. Werner. Yes. Yes, I'll complete. I'll take more time, but on the afternoon session only. We are having college unexpectedly tomorrow. But see, nomenclature, Werner's, we can finish if we spend 3 hours time. Last category, pi electron donor ligands. Ketra, are you there? Ketra. Pi electron donor ligands. Simple definition and few examples and close the ligands information. Okay. Ligands which give their pi electrons are the molecules which give their pi electrons are called as pi electron donor ligands. For example, see ethylene. Ethylene gives its pi electrons. Okay. What is its name? IUPAC nomenclature. 1,3-butadiene. It also gives its pi electrons. Pi electron donors are called pi electron donor ligands. Ligands which give are actually not ligands, molecules. This is the correct word. Molecules which give are species. Molecules which give pi electrons to CMA, central metal atom, are called as pi electron donor ligands. See example 1, example 2, benzene also. Okay, and fourth one, cyclopentadienyl anion. All these are pi electron donor ligands. In NEET didn't ask the question, but you prepare.